Welcome to this session on microcontrollers. In this session, we are going to see the basics of microcontrollers. Why do we need to study microcontrollers? What are the applications of microcontrollers? And the basic block diagram of a very simple microcontroller 8051. This is a series of microcontroller ICs that is being used in all our day-to-day applications. You will be amazed to see that all our day-to-day applications and vital applications including medical, industrial, automotive and automobile industries use microcontrollers in all of their aspects. So, what is a microcontroller? It is an integrated chip. It consists of all the components that is required for computing. Say it includes the processor, the memory chips, all the memory requirements, the I/O ports, serial communication ports and all the peripheral devices are packed into one single chip. Now, how this is possible? This is possible using VLSI. It is a very large integration technology to design ICs. ICs are nothing but integrated chip. In VLSI design, ICs are packed with more than 10 lakh components. So, this makes the ICs more compact and also it increases the processing speed. So, you could see from this slide the microcontroller consists of the processor, the RAM, the program memory, AD converter, oscillator and other I/O peripherals. Now, before going to study the characteristics of microcontroller, it is better to see how it is different from microprocessor. So, microprocessor is again an integrated circuit, it is a single chip processor. So, how it is different from microcontroller? So, if you consider a microprocessor IC, it has only CPU. All other peripheral devices like RAM, ROM, I/O ports, timer are outside the IC. Whereas, if you consider your microcontroller, everything CPU, RAM, ROM, I/O, timers, serial, COM port, everything is packed in single IC. So, that is the advantage. Okay. So, we will be able to appreciate the design, the various characteristics of microcontrollers only if we know the enormous applications of the microcontroller. So, the need to study the microcontrollers comes out from the fact that it can be found in every walk of life from simple computer electronics to high-end medical, automobile, industrial and defense applications. So, you could see that it is being used in automobile, aeronautics, space, rail transport, mobile communications, industrial processing, computer application, remote sensing, robotics, consumer electronics, music players, security and so on. So, from this slide you can see how it is being used in all the gadgets we use in daily life. So, it is commonly used in embedded systems such as in home appliances, security system and industrial automation systems. In automotive applications such as engine control units, airbag control units and anti-lock braking systems. In medical devices, it is used in heart monitoring, blood pressure monitoring and insulin pumps. In robotics, it is used in controlling robot arms and movements. In various consumer electronic products like remote controls, digital cameras and so on. In communication system, we use it in modems, routers and switches, and in security systems, we use it in access control system and alarm system. Okay. So, now we have an idea about how important the microcontrollers are. So, now we look into the basic components of a general microcontroller. So, every microcontroller has this CPU which is the brain of the microcontroller and it has two types of memory. One is program memory and the other one is data memory. So, program memory is mainly ROM, read only memory. Since these microcontrollers are mainly used as embedded systems for specific applications, so the program memory has instructions in it so which is specific to that application. So, that is why we use ROM, and data memory is random access memory, and we use timers and counters and IO ports, serial communication interface. Then you have interrupt mechanisms, CAN, SPI, I2C, DAC, clock circuit. Now, what is this CAN? CAN is nothing but controlled area network. This is used when microcontrollers are used in automobile applications, where all the control data relating to electronic circuits in the vehicle is controlled by this particular bus system, and this I2C is again used as a serial bus. Okay. So, digital to analog converter is nothing but which it converts the digital signals to analog signals, and we need clock circuit in all these ICs to synchronize the various events in the IC. Okay. Now, these microcontrollers can be classified based on the size of the bit it processes and also according to the memory device. So, based on the bit size, it can be an 8-bit microcontroller or 16-bit microcontroller or 32-bit microcontroller. Now, what is this 8-bit microcontroller? So, the idea of 8-bit microcontroller is it can process, whether it is arithmetic operation or logic operation, it can process 8 bits at a time. So, the enhanced version is 16-bit microcontroller, so which can process 16 bits at a time. Now, the 32-bit microcontrollers uses 32-bit instructions to perform arithmetic and logic operations. So, they are mainly used in automatically controlled devices including implantable medical devices, engine control systems, office machines and appliances and other embedded systems. Now, coming to the microcontrollers according to memory device, they can be classified as embedded memory controller and external memory controller. From the name we can understand that in the case of embedded memory controller, all the functional blocks including memory and other IO ports are present in a single chip. 8051 is the best example for embedded memory microcontroller. So, if you take the external memory microcontroller, the memory is outside the IC. So, it is not available in the integrated chip. So, the example for that is 8031. Okay. Now, these are some of the example microcontrollers classified under 8-bit, 16-bit and 32-bit. So, we have Intel 8031, 8051, and in 16-bit version it is 8051XA. Similarly, you have PIC 1X, 2X and 3X, and you have Motorola ARM controllers and then Atmel family. Now, we are going to discuss a little bit detail about the basic block of the 8051 microcontroller. Now, what is this 8051 microcontroller? It is one of the first and most popular microcontroller, also known as MCS51. It was introduced by Intel in the year 8051. It was introduced by Intel in the year 1981. It is an 8-bit microcontroller, which means the data bus is 8-bit, so that it can process 8 bits a time, which we have seen already. It is widely used in embedded system like robotics, remote controls, automotive industry, telecom applications. Now, what are the features of this 8051 microcontroller? It has 4K bytes internal ROM, 128 bytes internal RAM. These two constitutes of program memory and internal data memory. Then it has 4 8-bit IO ports specified as P0, P1, P2, P3 and 2 16-bit timers and counters and 1 serial interface. Then it has 6 interrupt sources, 2 of them can be external, 3 internal and the other one is reset. And it has external program and data memory. The size of the program memory being 64K and it is only readable, and it has 64K external data memory in which you can read and write. So, you can select whether it is internal or external code memory through EA, and there is one chip oscillator to generate clock pulse. So, this is the pin diagram of 8051 and it is related to the various blocks. So, as we saw, 8051 is an integrated chip. It is designed using VLSI. Now, this IC has 40 pins, 8051 IC has 40 pins. You could see the pin diagram. Of these 40 pins, we have already seen there are 4 8-bit ports, P0, P1, P2, P3. So, most of the pins are used for those ports. So, pins 32 to 39 they are used for port 0, pins 1 to 8 they are used for port 1, pins 21 to 28 they are used for port 2, pins 10 to 17 they are used for port 3. Now, these pins are not only used for one specific purpose, they are multiplex, they are used for dual purpose. So, if you could see the pins used for port 0, that is pins 32 to 39, not only they serve as port pins, but also they are used for address, multiplexed address and data bus. Also, the other pins used for port 3, they has interrupt pins and read and write pins. So, these 40 pins are multiplexed to do various processes. Now, this is a block diagram of the 8051. These are the basic functional blocks. So, we know that CPU is the brain of this microcontroller. Now, this CPU is getting inputs from an oscillator, that it receives clock pulse from the oscillator, and also it can receive interrupts through the interrupt controller. We already saw that the internal memory has ROM and RAM. The program memory is 4K byte ROM and the data memory is 128 byte RAM, and it has two timers, timer 0 and timer 1, and it has a bus control system which controls the entire bus system inside this 8051. So, when I say bus system, there are three types of bus system: address bus, data bus and control bus. Address bus carries address, data bus carries data between the various functional blocks, and the control bus carries the control data. And it has IO ports. As we saw, there are 4 IO ports: P0, P1, P2 and P3, and there is also a serial port. So, all these together they form the functional block of this 8051. So, coming to see them in detail. So, we know that interrupts are used to interrupt the processor whenever it is necessary for any priority operation or any emergency. Actually, 8051 supports 5 interrupt sources which can interrupt the normal program execution to handle specific events. And we saw that CPU, the central processing unit, is the brain of microcontroller. It is responsible for processing, executing arithmetic and logic operations. It consists of ALU, accumulator, registers and program counter to do this processing. Next comes the oscillator. As we saw, these external oscillator, it generates the clock signals necessary to synchronize the various events inside the microcontroller. And also we saw that bus control, which controls the various types of buses inside the 8051 for proper communication between the peripheral devices. And then we saw there is a 4K byte ROM which is used for storing the program instructions. It is only read only, and then we have 128 byte RAM which is used for storing the data that is used by program instructions during runtime. And we have input output ports. We saw that there are 4 8-bit input output ports that can be configured as either input or output, and it has timers. So, we saw that there are 2 16-bit timers or counters that can be used for variety of tasks, for measuring the time intervals, generating signals, counting external events, so on. And then we have a serial communication interface where data is transmitted within or outside the system using serial communication, that is 1 bit at a time. So, with this we have seen the basic idea about microcontrollers. So, what is the need for microcontroller, how they are used for various applications in all our day-to-day life, and the basic concept behind the microcontroller, their block diagram, and to be specific about 8051, the block diagram and the specific features of 8051. So, in the next video we will see the architecture of 8051. Thank you.